Okay guys, welcome to my class once again. I have these two sets of equations on my board, and the first one is the hydration of Alkanols. Although I've not thought about Alkanols, but you are coming there, but this equation or this reaction is very important. And the second one, we have hydrolysis of alkenes. Remember, we are still on alkenes. Okay, now look at what is happening here. The hydration of alkanols is a laboratory method of preparing ethene. Remember, one of the of alkenes we have in the group is ethene. That is C2H4, ethene. Now we can use this method. This is alcohol, and this is H2SO4 tetraoxosulfate 6 acid. We can use these two reactions to produce ethene, and also we can hydrolyze this ethene to get the same alcohol. Try to understand. This is ethanol, and this is H2SO structural, the structure of H2SO4. Here is ethene, and here is also H. So these two equations or reactions are very important to us as chemists. Now, the hydration of alkanols, for example, ethanol, can give us ethene and H2SO4. While hydrolysis of alkenes, that is ethene, will give us ethanol and H2SO4. So let us see the product of the reaction. But one thing that makes these reactions unique is they have an intermediate product. And this intermediate product is the one that gives us the final reaction. That is ethyl hydrogen tetraoxosulfate 6 is always the intermediate. So let's go, guys, let's demonstrate this. The first product or intermediate product here, remember, this one is the hydration of alkanols. For example, we have ethanol, C2H5OH. That is what we have here. Okay, so let's see the first intermediate product it will give us, and let's see what we are going to do to that product, that intermediate product, in order to arrive at the final product. So what we are going to do, look at this equation. The first thing that will happen here is this OH will move to form water with hydrogen atom from this OH group. Why the whole of this will be attached from here to this with this pen. The whole of this will be attached there. That is what is happening. And why this OH and H will form water. That is the first intermediate product. So if we go by that, we are going to have, look at what we are going to have. We still have this, but it's only H that will move out from here. So I can start from here. That is being liberated here. Look at what is formed. This compound is known as ethyl hydrogen tetraoxosulfate 6, which is C2O4. This is ethyl. Okay, this compound is subjected to decomposition. And when you decompose this, when I say decomposition, it means heating. When you heat this ethyl hydrogen tetraoxosulfate 6 position, when this is decomposed, so now we are going to decompose this. Let me shorten this. We are decomposing, at 170 degrees Celsius. When we decompose this ethyl hydrogen tetraoxosulfate 6, then we are producing ethene, which is double bond, plus this X and OH. So this is ethene, and this is H2SO4. This the laboratory preparation of ethane or alkenes. This equation is very important. Laboratory preparation of what? Alkenes. We can prepare alkenes from the laboratory by simple dehydrating alkanols. When we dehydrate them, we are going to have an intermediate product, which is ethyl hydrogen tetraoxosulfate 6. Then you decompose it to get ethane and H2SO4. Okay, guys, follow me. Let's go to this. And I told you that this is hydrolysis of alkenes. Let's see when these alkenes, example ethane, is hydrolyzed. Let's see what is going to happen. When we hydrolyze this, we are still forming the intermediate product is still here, because this H2SO4 readily absorbs ethane. H2SO4 readily absorbs ethane. So the same intermediate product as I demonstrated here is the same thing that will happen. One of the H will come to attach itself to this bond, thereby changing this bond, okay, to single bond. Okay, yeah. Then in this case, we are going to have this. Look at what we are going to have. We are going to have this. Okay, it will come and attach itself here. This will come and attach itself here. So the product we are going to have here, let's go, is X. Before we have only 4H, then H becomes 5 and the double bond disappears. So in this case, look, this is the intermediate, which is still C2, which is still C. If you check this equation, you will simply say that the equation is balanced. So when you subject this equation to what we know, this intermediate, to what we know as hydrolysis, when it undergoes hydrolysis, under water or with water, when it undergo hydrolysis, what we are going to prepare or what we are going to form is ethanol and H2SO4, which is ethanol plus we are still having our H2SO4. So ethanol is produced here. While H2SO4 is also produced. Look at this. Here, an alkanol is dehydrated to produce ethane. Here, an alkene is hydrolyzed to produce alcohol. These reactions are very, very important. Please take note. I hope you enjoyed it. Bye-bye.